Hey guys, welcome again in Eng-Man YouTube channel. So today we are going to have another episode of WellFlo, and in this WellFlo video I'm going to show you a practical case of a well. Actually it's about a water source well. So sometimes we use or we work over or even we drill a well for the objective of providing supply water, makeup water for our water flood or water injection operation. So I'm going to prepare or I want to model a water source well. And I will equip the well with electrical submersible pump. And of course, I will do the modeling using WellFlo software. Okay, so let's go ahead. So this is the dashboard. It's not a final model. So actually, I already have a sort of almost done model, but I think I will check each of the value and maybe I will do some corrections to the model. Okay, so it's a practical case. You can follow me if you also want to know about well modeling or specifically water source well modeling. Okay, so here we are in the dashboard, model navigator, and then initialization, general data. Okay, company Eng-Man, well, number X, field YT, okay, YouTube, and analyst Eng-Man, whatever you can input these cells whatever you want. And then well type and flow type. Of course, it's producer, it's a water well, and we will use electrical submersible pump. Of course, the flow type will be through the tubing, fluid type black oil, and the well orientation, it's vertical. Both vertical and directional or deviated well will be modeled by this vertical mode. Forward and flow correlations, you can start with you know, the traditional flow correlation like Hagedorn Brown, Bex and Brill, Duns and Ross. But if you already have sort of study or statistical study to determine the best the best correlation to use, you can also use that. Actually, the best thing is of course by conducting tuning or matching, but in this in this particular example it's a new well, so we don't have pressure or gradient survey data that we can match on. Okay, so I'm just going to use the traditional or the basic flow correlation, Hagedorn and Brown in this case. Okay, and then reference depth, well type onshore, and zero depth at wellhead. Okay, so we have the distance or the location of the Kelly bushing, where the Kelly bushing is, and then the Braden head or the wellhead, and the KB distance to Kelly bushing minus distance to the wellhead or Braden head, KB minus BH. I use that and do some adjustment. Okay, basically we are defining or we are setting the zero depth in this selection. Okay, so I'm going to measure all my distance based on the wellhead position. Okay, so please be careful because depending on how big, how large, how great the distance to the Kelly bushing or rotary table, it can make some errors in your calculation. Okay, so I will be a little bit careful here. I use wellhead. Okay, fluid parameters. PVT calculation method, black oil, and it's actually water well, so all these numerical values don't have significant meaning, okay? But the most important thing is here, water salinity. In this case, 10,000 ppm, and here, the water gravity will be calculated automatically. And then gas specific gravity, if you have gas flow, 0.7, it's a typical value. And if you want to generate the PVT information, you can expand this little window and then you can just click on calculate button here. Okay. But of course, all these calculated values will be used during the simulation, during the modeling. Okay. So I'm going to click on apply, forward, and then reservoir.